Hey everybody, this is Brad Dyke, coming up with the third part of this little experiment of mine in making this super tiny little NAS. And what I'm referring to is what I'll show you right now. So here's our cute little NAS. Very tiny, very out of the way. I've got two SanDisks and three T-Group SSD drives in there without their case housings. As you can see, they're much smaller than a traditional 2.5 inch, which is what I've used in these shell casings. This is the original size right here. But as you can see, I put quite a few of them in a very small footprint. Sent them out by USB cable to a consolidated hub over here. And at this point in stage, I'm going to go ahead and put my keyboard and mouse in real quick. Okay, so now we've got keyboard and mouse, so I should have a functional mouse. I do. So we basically have a typical installation going on here. Change a couple of these things. Get this kind of stuff set up real quick. So while that's going through the process, as you can see, my states of my drives are present. They are operational. We've got a 64 gig disk in here, mini SSD card, or a mini SD card that is. And of course, as you can see, the Raspberry Pi 4 here, which is burning pretty good. Very simple format. One USB in, I prefer it that way. One HDMI out, one power source, but not driven by the interface. Okay, so what we've done now is we've started the process of prepping the operating system, getting it on board, doing some updates. We're going to do a compile update. I just want to show you how small this is, literally how tiny it really is, and how definitive the SSD card logic boards are really pretty small. Granted, they're not as small as something like, a micro NVMe type interface. In this case, this is more of a wireless interface than anything else. But the key thing is, dealing with the NVMe standard footprint for micro configurations, this is still pretty doggone good and extremely cheap. So with that being the case, I've got the Raspberry 4 Pi here. I'm going to be doing an update on the operating system, and then I'm going to load ZFS configuration to the Raspberry Pi, and then that should allow me to start grouping these up. Now remember, I'm not going to build or pick a version of NAS head I want. That wasn't the goal. My goal is can I get natively a standard NAS principal device built in a very, very, very small footprint? And the answer is yes, I can. Not only can I can really do it really easy, using a lot of consolidation. Now, granted, it is USB, so I can only go to the speed of 3.0, but that's okay. I mean, this wasn't about high performance. If it was high performance, I would go something like NVMe, and it would be actual busing NVMe, which is very common to see these days out there in the industry. A lot of kids are doing that right now, but I just wanted to show you that there are other ways to make Raspberry Pi NASs that aren't expensive, because I only paid like $40 for each of these. These parts and pieces were in these little plastic filaments here, were about $20 total, for different sizes and shapes. You can get them in all types of assorted values. Had an 8-port hub right there, not a big deal. Had spare components of a 2.5 inch drive, SSD drive housing. So I just repurposed it basically and took advantage of that as well. And of course, no frills, Raspberry Pi standard with Wi-Fi functionality. So I will eventually use the Cat 5 connection over here on this side just for NFS style type connectivity. That will give us both the ability of doing low-end NFS or equivalency of EFS, as well as IP-based storage. Now, while this is finishing up the operating system updates here, part of it that is, I will show you that I use these spacer sets here to adjust. Now, when I did my previous version of this video, I showed you that it was kind of limpy, right? Kind of weak and kind of shook a little bit. It wasn't very stable, but now it's very stable. These are very very well within their bases. They have proper spacing. Some of them have heat sinks on them because I'm just doing some heat sink testing. But I've got the spacers in there now to properly space the gaps, because these bolts here weren't exactly the best fit. They needed to be just a little thicker, so I used the spacers to adjust for that. As you can see over here, I have them as well on this side. So all in all, this is a pretty cool little get up here. You can put this in a bag, really easy, or you can put it into a mount board, and you could just put it in a suitcase, and small suitcase, like a briefcase, and you just set it up, and it's ready to use, and it does everything you want to do, and then you just pack it up, and you get it out of there, and you're done. It's pretty cool. So, because it has a Wi-Fi bridge in it, you could actually use that as a gateway device, so your laptop could connect to it, using it as a localized router that doesn't go anywhere, but it provides IP-based storage and connectivity, as well as general network trafficking, which is really nice. Now here we have a statement here that's saying system is now updated. Alright, man, I say what, that looks a little fuzzy, doesn't it? Hang on a second. Okay, that seems to be a little bit better. So now we're allowing it to reboot and get itself into a good place. And then at this point in stage, I'll be prepping for the ZFS load. Let me take a couple of minutes to prep the OS. I'm not going to do anything special. I'm just going to run the ATP update command and just make sure everything is squared away on that side of the fence, because I hate to run into those barriers when I'm doing the other work. So hang on for just a second while I prep that. Okay, so we're now going through the process of doing some basic quick down and dirty operating driver updates and OS updates. So we're going to let that run us through. And in here, Raspberry Pi, there's a reference article here, as you can see. I'll zoom in real tight there so you can see the URL. 5-second hold. All you have to do is just simply type in, install ZFS on Raspberry Pi 4, and this page comes up pretty quick. But as you can see, I am good to go on that front. So now what I'm going to do is working this strategy to build a installation for the ZFS header utilities, and I'm going to pull those in. Now the cool thing about that is I can go over here and just simply, we'll do a quick update one more time, and we'll stretch this out some more. And what I'm basically going to do is I'm going to be stealing these commands, and I'm going to run them over here real quick to get them to install on this environment here, and get that going. All right, there we are, good. All right, we're going to let that install. This is bringing over the ZFS utilities for Linux. And since we have a primary Linux kernel here, we're going to be able to use it. At least that's the thought. We'll let that run through. Okay, we're at recruiting at 62% of the build for the operating system, just to give you a quick status update. After that, we're going to be running full upgrade yes, and then initiate a reboot, which will then bring the ZFS core services into an alignment, and that should be all we have to do. We are pretty much clean. We can do what's called a post cleanup if we want, but since this is a 64 gig SD card, I'm not going to worry too much about that for now. Principally, I'm focused on just getting it to the good point. So I'll pause the video again until it gets to the end. Okay, so we did complete the ZFS install utilities tool, and so now what I'm going to do is I'm going to initiate a reboot, as you can see there. And the Raspberry Pi is going to reboot, and it's going to come back with the ZF configuration tools that I want to see. While this is posting, I will be right back. Okay, so we've got everything back, and we are now looking at our disks. There's our two 119s and our three 238s. And if you look down here, that's these. So outside of that, you'll see the 64 gig allocation down here. That's the SD card. So by installing the ZFS utility tools, we can now do ZFS. We can form pools, and we can do quite a bit now because we were able to bring these in, and I could create 2 disk drives in this, and I probably will. And that principle would be to provide probably a stripe set with parity with the 238s and 2 mirrors with the 119s, just to see how well they perform in general for file dumping and NAS heading and so on and so on. But I just wanted to show this to you just to give you a kind of a bird's eye view of what it looks like. It works, it's functional. You use the lsblk command to display your drive states once they are there. If I drop the USB output on this, those disks would vanish very quickly, and then I have to bring them back in again cleanly, but I'm not going to do that, obviously. What I'm going to do is I'll leave these in a paired state, power the principal Pi down, and leave the USB drives on standby so that they'll be there active. And I'll probably remerge this into another video talking about how I'll package this all into a very small case housing of some type, so I can put it up into the rack enclosure up here. I just don't know where yet, but it will be cool to have its legacy. I'll never do it again, except for maybe using it for some buffering. I could do some NFS, what's called transaction dumping. That's where you create dump files using low-end NFS connections to allow you to scrub files out and clean them up and then destroy and rebuild them and so on and so on. But I just wanted to show you guys that this is doable and is done, has been accomplished. And yes, technically you could put another USB hub and add more of these. Just understand that you're not going to get the performance you expect. Well, this is Brad Dyke saying goodbye. You guys take care and God bless.